One of the things that we have not talked about in regards to object-oriented programming in ABAP is the ability to have static attributes and static methods. And so the idea here is normally when we have a class that we define and we have attributes that we define of that class, or we have methods that exist in that class that we want to call, normally we have to create an object based on that class definition in order to be able to use those things. And in fact, the attributes are not actually instantiated until we create an object of a given type. And the idea here is pretty straightforward. If you think about it, we have been working on defining a vehicle class. And in our program, we might create 3 different vehicles. And I think one of our attributes was the number of wheels. You know, you could have one particular vehicle that has 3 wheels, one that has 5 wheels, one that has 8 wheels. I think we have color as an attribute. You know, you could have a red one, you could have a green one, you could have a blue one, and so on. But the idea is, until we actually write a program that instantiates the vehicle object, we have nothing. The class definition in and of itself does nothing for us. Until we actually create a vehicle, it doesn't make sense to call a method called getColor because you don't have a vehicle, so of course you can't ask what color it is. Well, the idea behind static attributes and static methods gives us a way to create a class structure and put attributes and methods in it, but not have those things be dependent on instantiation, meaning they exist essentially all the time in our program and are made available to us on demand. Now, there's 2 different ways this could play out. You could have a class that essentially everything in the class is static, and we'll work through an example of that. Or we could incorporate static things, static attributes, static methods into normal class definitions to give us something like, for example, an instance counter. Let's say, for example, in my program, I wanted to keep track of how many cars or how many vehicles had actually been created. Well, what I would need is I would need a variable that essentially would be shared across all vehicles and could see all the vehicles for the sake of keeping a count. So that's what we want to talk about today, and mainly I want to do this by having us look at the code needed to make this. But the idea here is anything that I declare that is static in nature, and static is the traditional term for this, but in ABAP, the actual term we use in our writing of code is we call this class data or class methods. These are things that are shared amongst all of the objects. They actually belong to the class itself. And so we will, for example, see things in our code that looks like this. And in this case, we have an attribute called name, but notice in lieu of it just being a normal data statement, this is class-data. So what this would mean is, no matter how many instances of example class I instantiate, and even if I don't instantiate any, all of them share the name attribute in common. So if you will, if we were doing something like this with vehicle, we would have 3 different vehicles, perhaps, that have been instantiated in our code. But in terms of, in this case, name, all of them would be sharing the same name attribute. It would cut across all instances of all objects that have been created. So let's take a look at a couple of different ways this could be useful. And what we're going to start out with is the idea of, suppose you want to make a class that would just have data and methods in it of kind of universal purpose. And so you might want to drop this into a variety of different programs that you would create. And you wouldn't necessarily want to have to instantiate this in terms of an object. Well, if you're not following exactly the scenario here, hopefully as we write the code here, it'll make sense to you. So what I'm going to do is I'm going to create a class called MathMe, where I will include a bunch of math-related things. And we're going to assume, for the sake of this, that the things that we're going to put here aren't already built into our development environment. And so I'm going to have the class MathMe definition, and I'll go ahead and put in my end class statement, and then I'll have the class MathMe implementation and end class. So far, this looks exactly like we would expect. And I'll come up here, and in my class definition, we'll introduce a public section. And one of the things that I could have as a part of this, and this would just be illustrative of this, is let's say, for example, that I wanted to write a method that would, well, actually, we've only talked about attributes so far, so let's talk about actually, what I want to do, let's go to the next slide and let's talk about methods and attributes together, and this will make a little bit more sense. Class methods can be defined, and a class method is something that is shared universally. The thing about a class method is it can only access static attributes, but once again, I don't have to actually instantiate an object to make use of these. And so let's look at this. So here's my example. I want to create a method. So I will call this class method, and I'm going to call this method square, okay? And this will give us just a good opportunity to brush up on our ABAP coding in general here. And the idea of this is pretty straightforward. And by the way, this is actually class methods, since we're in the definition section. And so pretty straightforward idea. This is going to take in a number, and then it's going to return the square of that number. Now, let's kind of start writing this, and we're very quickly going to run into some things that we have to take into account. But let's start writing it and see what we run into. So here's the basic idea. We're going to import a number. So we're going to import, and we'll just call the variable here val. And then we're going to return, so we're going to have a returning statement. And remember, with returning, we always put value here, and we're going to return the answer. So we're going to take in a value, and we're going to return an answer. So one of the things that's not nailed down at this point is I need some data types here. So let's say, for example, I tried to do this. Importing val, type P, length 5, decimals 2. And you can probably already pick up on the idea that because we're starting to see red text here, we have a problem. And in fact, if I went down here and said type P, length 5, decimals 2, we've got a lot of red going on here. And one of the things that I mentioned previously that particularly has to do with the returning construct is the idea that we can't use incomplete data types. We would have to have our own user-defined types. So let's add this to our class definition here. In the public section, we'll create a public type, and we'll just call this type math number. And we'll say that this is type, actually this is types math number, and this will be type P, length 5, decimals 2. And then I'll come down here and say that my square method imports val of type math number, and it's returning an answer of type math number. So you notice no red. We're good now. And my implementation here I don't think could be any easier for this. But this is a class method. So I come down here, because I've already identified on line 11 that it's a class method. Here I just use the normal word method with my implementation. So method square, and my code is just going to be answer equals val times val, end method. So nothing earth-shattering going on here, I don't think. And we now have, we'll do a check here, we now have a valid class definition. But the key thing to pick up on is this is a class method, which means that I do not have to instantiate mathme in order to call this method. So let's look at what I'm talking about here. Now I can come down here and introduce a start of selection, and I can do this, write out to the screen, and here's how I call things that are static. Instead of using dashed arrowhead, static things are equals arrowhead. So what I'm going to do is I'm going to call the square function, or the square method, excuse me. So square, and I'm going to ask it to square, we'll start out simple, the number 7. So notice once again, no red, that's a good sign. Let me move this up a little on the screen so you can see more easily here. So notice I didn't have to instantiate the mathme class because I'm just using a part of it that is static, and I'm making a call to the square method, and if we execute this, we will in fact see that it prints out on the screen 49 is the answer. So let's play around with this a little bit more and talk about the fact that the idea here is anything that's static is universally shared, okay? So we could do things like this, and this isn't necessarily an illustration of static, but we could do something like this. We could say constants, pi, type, math number, value, and it's probably going to complain because I have this before my type definition of math number, so I'll move it here in a second. 3.14, which isn't a very precise definition of pi. Let's see if it'll actually let me get away with leaving that where it is. Nope, math number is unknown, so we'll swap the order of these two lines of code so that it knows what a math number is. Okay, and so now I could actually do this. I could say mathme square, mathme pi. And so now it's going to take the value of pi, which I've only defined to 2 decimal digits, and pass it to the square function, and in this case just write that out to the screen. So the idea here is nothing here is actually based on an instance. I don't have to instantiate this mathme class. And in fact, if I were so inclined, I could keep adding more and more methods to this, and then eventually I could put this in the ABAP dictionary, in which case it would be truly universal across the whole system, and anytime anybody wanted to make use of this, all they would have to do is reference the name of the class and then use the appropriate symbology here, the equal arrowhead, to reference either, as we're seeing here, the name of a method or the name of an attribute. So, but the idea here is because we don't instantiate this, these are things that are shared across all of our instances. So let's go back to the other program we've been working on, which is our vehicle program. So let's look at this scenario right here. I want to keep track of how many vehicles have actually been created. So the idea is when my program starts, there would be 0, And then if the first time I create one, my counter goes to 1. Then when I create another one, the counter goes to 2. And if you think about that, this would have to be an attribute that is universally shared, because in essence, all of these classes have to know about each other. All of the objects have to know about one another. So the way we can do this is through introducing a new attribute. And so we'll do class data, and we'll call this counter, type I. And it's not a bad idea for us to do this. We can go ahead and initialize this to 0. So this is now a counter that will be shared across however many vehicles I have. There's only one counter. So the scenario I had for you is, every time I create a vehicle, I'm going to have to increment the counter. How could I do that? That's exactly right. The perfect place for this is in the constructor. So if we go down here to the constructor now, all we need to do is add to the logic of the constructor the idea that count, do we call it counter or count? Counter. Counter equals counter plus 1. So now every time I create a vehicle, that counter is going to be incremented. And by the way, do we put this, let's look at this, we put this in the public section, so really this should be designated as read only. All right, so now let's just see how we could use this. We could come down here, and on line 132, we created a sports car. Let's wipe out some code here just because we're not going to need it anymore. And what we'll just do is this, is we'll say write out, and in this case, we list the name of the class. So the name of the class is vehicle. Counter, okay? And let's do this just to illustrate this. Let's go up, and right after the program starts, let's write out the counter. And then we're going to create an object of type vehicle, and then we're going to write out the counter again. And so what we should in fact see here is a 0 printed out and then a 1 printed out. And just to illustrate this, because we can, let's go in here and let's create data my sports car 2, create object my sports car 2, my sports car 3, create object my sports car 3, my sports car 4, create object my sports car 4. I'm just relying on the default constructor here because I'm not passing in any attributes. And then write vehicle counter. And so we should now see this print out 0 and then 1, and then if I counted right here, 4. And in fact, that's what we see. All right? Any question about the concepts here? A attribute that is declared to be class data is shared universally across all objects, and as you saw here, when I call it, I use the name of the class, not the name of the object, and use the equal arrowhead. And we saw between our two different examples we worked through, both calling a class method and referencing class data, which would be a class attribute. Any questions about this? Let me, yeah, go ahead. Could be private. Yeah. Then you would have to create a accessor or getter method, which you could do. Or, you know, it's not wrong to make it public as long as you protect it with read-only, I think is fine. Yes, sir?
Is either way more common?
In ABAP, it is pretty typical to do the public read-only because it just makes your code easier and more condensed. Now, I did something in the first program we wrote that I don't know that we explicitly talked about before, but here, when we defined our class, you'll notice we did color, type string read-only, wheels, type I read-only, gas, and so on. But you'll notice we didn't define a default value, whereas in this program we created just here a second ago, we use the constant statement, and with a constant you have to do this, but we set a value upon instantiation of 3.14. Well, if you really think about what we did for a second, remember last time how we talked about with the constructor, we could do things like this, setting default values. Well, let's think about this for a second. Everything we did here is perfectly fine and valid. But do you see how we could also, for example, say, all right, color, we're going to have it, we wanted it to default to the value unknown. Well, what I could do is I could take that from there, and I could go up here to my attribute definition, and I could, got to change keywords here, but it's the same concept. I could do an initial value of unknown, and then if I wanted to, I could come down here, and I could make this optional. Now, we still are going to have to account for the fact in the logic of my constructor that the user may or may not have set color, so I'm still going to need that test that we looked at last time to see if it was defined. But I just wanted to point out that in a lot of cases there's more than one way to accomplish things, and I think that where we were 5 minutes ago arguably gave us code that was a little bit clearer. But you will also sometimes see code that looks like this, where you have parameters that are declared to be optional, and default values are actually placed on the attributes themselves at time of definition of those attributes. So that ties back to this thought that I dropped at the bottom of this slide, which is attributes, whether they're static or instance, can use the word value upon declaration to set a default value if you are so inclined to do so. Yes, sir?
Previously, you said that if we have a default value defined, then we don't have that it's by default optional. So since we've established a default value for that attribute, is it necessary to say that it's optional?
It's a really, really great question. And the answer to that is, and let me back up here to make sure I understand and answer this correctly. If I define this here like I have on line 18, that I might have, in talking about this, said that is the default value for it. Probably a more correct way to refer to that is say that is going to be the initialized value. And in fact, default only comes into play down here. So you're thinking along the right lines for sure, but one is the initialized value and the other is the default. And the default here is only, if you will, default in the context of calling that method, which in this case is the constructor, which gets called automatically. Okay? Other questions? All right. Let's look at this. And I put here, you can invoke a class method by using the name of the object as well. So just as an aside, the code that I wrote here in terms of our class data is perfectly correct. Oh, wait. I actually wanted the program I had loaded up here. And let's make sure I didn't break it in what I was just doing. Okay, so notice down here where I did write vehicle counter on line 144, I could pick really any of my vehicles at this point. So I could do my sports car and now make reference to the static counter. So it is in fact, oh, did I type this wrong here? My sports car, type my sports car, I think, let's see if that changes to that here. There we go. In this case now, if I am going to refer to it using the name of the object instead, notice I can still do that, but now it changes to the arrowhead. Let's run it to see that we do get the correct results here, which is 0, 1, and 4. Now, my suggestion to you is to write your code like what we're doing on line 137, and I guess where else do we show? On line 130, where I'm using the class to refer to it. But notice I can refer to it by using an object that is a member of that class or consistent with the type of that class, and then my symbology changes just to the regular arrowhead. But I'm still making reference to essentially that attribute that is shared across all the instances here. Let's see if there's anything else to tell you. We already covered an object is not to be instantiated to invoke a class method. Oh, I can create, if I need to, a class constructor. And the idea here is, or excuse me, a static constructor. A static constructor method can be created named class constructor. Let's look at this. Let's create an example of this. Or let me give you this rule. This method will be called the first time an object of this class is created, or the first time I reference a static attribute or method. So let's look at this as an example. Let's go back to our MathMe program. So I don't know what kind of setup we would want to do here. But let's assume that this makes sense. For us to have as an attribute here, class data, and we're going to call this date, and we're going to make this type D, read only. So this is now going to be shared. I'm not going to have to instantiate MathMe in order for this to work, and I have just now created an attribute called date. And here's what I want to have happen. When the user runs his or her program and references this, and I don't like the word date because that could collide with things. So let's just call this today date. What I want to have happen is I want this to show today's date. Now I could get at this a few different ways, but just bear with me as we illustrate this. So the idea is I'm going to have to initialize this. So I can now come down here and I'm going to have to create a class methods, and we said that this gets called class underscore constructor, and I'm not going to have any parameter passing associated with it. So I just have to say that this is what it is. So instead of having a method now called instead of having a method called constructor, I'm going to have a method called class constructor. And so now let's come down here, and we have to actually write this. And method class underscore constructor. and it's going to initialize today date. Today date equals, is it SY datum that has today's date in it? I want to say that's right. And so, end method. Now, there are other ways I could accomplish this, but what I want you to see is I created this static attribute called date. And in my mind, I've got to initialize this thing. So how do I initialize something? Or if you will, if I wanted to do some kind of calculation as a startup whenever someone uses this. The class constructor method is going to give me a way to actually do that. So let me check my code to make sure that syntactically we're okay, and then let's run this. So the idea here is the user could now say, write mathme today date. And today date, once again, is an attribute, so I'm going to expect to see this to write out today's date, and it does, 3/23/2017. So the point is that calculation or that determination of today's date happened inside of the class constructor. And that got called, our other constructor gets called when we say create object. Well, the static class constructor gets called just the first time we make reference to mathme anywhere in our program, which in this case happens in the same line when I actually used it. Now let's just see as an example, I could write hi from the class constructor, okay? And so you should generally not do what I'm showing you here, but you see that what happens is the first time I make any reference to it. So even, for example, if I did this, if I said data D or data dat type D equals mathme today date. So notice the heart of my program here isn't actually writing anything to the screen. All I'm doing is making reference to the mathme class on that line right there. And so we are going to, in fact, see that that still results in, whoops, field D is unknown. Oh, I changed that to dat. My class constructor gets called upon first reference. And in fact, if I use the mathme function a lot, don't know why you would do this, but just to show you, if I make a lot of reference to the mathme class, the class constructor only gets called the first time I reference it. Okay? Questions?
Where did the date go once we did the reference that way?
I just stuffed it in a variable I created there. Other questions? Yes?
So the method name, class_constructor, is just like reserved by the system.
Mm-hmm. Yep. Just like the method name constructor is. And you could have both a constructor and a class constructor if you needed to manage both static attributes and traditional attributes. Yes? Yes.
You can only initialize static attributes.
That's a good question, and I want to give you the rule about that because I think we have that on our very next/last slide that we'll look at today. Static methods can only access static attributes. Static methods can create their own local data objects if they want. Instance methods can access both static and instance attributes. But a static method can only reference static attributes. And if you think about that for a moment, it makes sense. Instance attributes only get created when we create an object. Well, The whole point of having static things is I don't have to create objects to use them. So a static method, of which the class constructor would obviously be an example of that, it can only reference attributes that they themselves are static. It can create its own local data if it needs to, but it cannot reference traditional attributes or instance attributes. Instance method, on the other hand, they can cross over. They can reference static, or they can reference instance attributes. And we saw that already because we saw that our constructor could increment the counter. And that's exactly what I have here. Don't know why that says construction. It should say a constructor may modify static attributes. Okay. Questions? Yes.
So, static methods can only be called for equals, greater than. You would use that for the class constructor as well, class underscore constructor.
It gets called automatically. So you would never have an error, you would never call it explicitly. Just like you never explicitly call a normal constructor. It gets called automatically. The normal constructor gets called automatically every time you create a new object. The class constructor gets called one time, and that's whenever you first make reference to a class anywhere in your program.
So with other static methods, then you can access them with the equals, then the greater than.
Mm-hmm.
And if it's just a regular method, so a dash,
Mm-hmm.
then a greater than, okay.
You got it. Okay. Other questions? Okay, let me explain what we're about to do next.